For this scenario, this calf raise exercise, we're trying to find out the calf muscle force, also the joint reaction force. They're both unknown. We don't know the calf muscle force and also the joint reaction force. So we're trying to find out that. The only information we know is the person is 150 pounds, and then so that 150 pound going downwards through the toe ball when you perform a calf raise exercise, and then you get the exact same ground reaction, which is 150 pounds. So that force is known, and there's distances we can measure that is known as well. Now, this scenario is actually the last final position of the calf raise, but this question is asking when the foot is flat on the ground, you're about to move, almost lifting yourself. So calculate forces in that scenario. I just take a picture like that just to demonstrate how a calf raise look like. The video that I explain how to find the unknown for liver problem, typically you take moments with respect to the fulcrum or pivot point. Now, sometimes it is difficult to know which one is the pivot point, which is the fulcrum. Is it the joint force or the toe ball? Is it the joint ankle joint, or is the toe ball is the fulcrum? Um, the goal here is to cancel one of the force by taking moment in a way. So if you take moments at the passing point of one of the force, then other force, that particular force will cancel out because there will be no moment because of that force, because the distance is zero. So the goal here is to, not to figure out which one is the pivot point. It's basically when you're solving problems is to figure out why should I take moments to cancel one of the unknowns. So in this case, let's say we're trying to find out muscle force, then you take moment here at the joint. If you're trying to find out the joint reaction force, then you take moment at the muscle. So that will cancel the muscle force. So if you take, for example, moment counterclockwise positive, all sum of moment is zero. Let's say we're checking with respect to the joint, ankle joint. So simply this muscle force will make this whole foot the clockwise movement. As you can see here, with respect to this point, this pivot point is this muscle force right here pulling upward will make a clockwise moment. So that's going to be negative. So muscle force times the distance from the joint is 1.15 inch. And this 150 pound will make a counterclockwise moment with respect to the moment point here at the joint. So that's going to be positive 150 pounds times the distance is 8 inch. Distance is from the place you take the moment. So that's sum to zero. So then you will be able to calculate the joint, the muscle force, which is 800 pounds to lift your body starting from the ground. The foot is still at the ground, not at this position. It is, as you can see, this is the flat at the ground. So still the foot is right here at the ground, just about to move up. In that point, you will need 800-pound force, muscle force. Now, if you want to find out the joint reaction force, similarly, you can do two things. You can apply moment again, counterclockwise, all moments sum to zero. Now you take moments with respect to the muscle insertion point, the Achilles tendon. So here, the muscle, if you take moments right here at this point, and everything sum to zero, then you can simply, this joint force will do a clockwise moment. That's unknown, which is negative, which is 1.5 inch from the muscle. And then this 150 pound, which is 1.5 plus 8 inch from the muscle force, from the place we are line of action we are taking this moment from. So which is positive 150 times the 8 plus 1.5 inch. If you solve for the joint force, it's going to be 950 pounds. There is another way you can find it without taking moments, because you can do summation of Fy is equal to 0 We already know positive, let's say upward direction positive. We already know the body weight upward direction, 150 pounds. Plus, we have calculated this muscle force 800 pounds. So we can do the 800 pounds minus the joint force, everything sum to 0. So that will also provide the joint reaction force 900 pounds. To summarize, your goal is to cancel one of the force. That's why you take moments with respect to the pivot point. Typically, the pivot point force is unknown. In this case, actually, the ankle joint is pivot point. However, if it's difficult to figure out which one is the pivot point, take the moments at one of the unknown forces so that that force get canceled and you can find the